All right, here in part C, we're going to revolve. Wow, I'm not really sure what happened there. I blacked out for a second. In part C, we're going to revolve this region around the line x equals 4. And so we're going to revolve it around this line right here. Now, since that line is parallel to the y-axis, just like part A of this example, we want to do everything in terms of y. So we want the y-coordinates of our intersection points. That's going to be 2 and 6. And we want to get the curves in terms of y as well. So remember, we solved and found that this parabola was x equals 2 plus or minus the square root of y minus 2. If you missed out on that, we did that by completing the square, and we did that in example A. You can go back and look at that if you don't remember how we got that. And this one in terms of x is x equals 1/2 y plus 1. That's our line. And remember that the parabola is divided at the vertex, and the right-hand branch is the one that we're interested in. That's the branch x equals 2 plus the square root of y minus 2. Okay, so setting this up, we're going to have pi times the integral from 2 to 6. Since this integrand contains y's, we want the y-coordinates as our limits of integration. And then we want the outer boundary. And the outer boundary of our solid is determined by the distance from the axis of rotation to the line x equals 1/2 y plus 1. And so we're again going to go big minus small. In this case, the line is further to the right than the boundary of the solid. And so the line, the axis of rotation, is going to go first when we write our radius. So we're going to have 4 minus the quantity 1/2 y plus 1. That's going to be our outer radius of our solid. And our inner radius of our solid is going to be the distance from the axis of rotation to the positive branch of the parabola, which is 2 plus square root of y minus 2. And we'll square that. And there's our setup. And now we're just going to go ahead and integrate this using our calculator. So we've got pi times the integral of our outer radius, which is going to simplify to 3 minus 1/2 y. I'm going to use x in my calculator, doesn't really matter. Minus, let's see, that's going to be 2 minus the square root, 2 minus the square root of x minus 2. Let's square that. Integrate with respect to x from 2 to 6. All right, took a little bit of time, but we end up with 8.378 as our volume for this solid. Okay. Again, if you need to see the completing the square to get x by itself, refer back to example A from this part A from this example. And other than that, it's pretty straightforward. And that's the end of part C of this example.